Right, this video is about cotangent. If you haven't seen the video on tangent, you need to stop right now and go back and go and watch that video. And you should also have watched the videos on sine and cosine and cosecant and secant. Because I'm not going to spend a lot of detail about why cotangent is certain values in certain places. I'm going to go over that relatively quickly. The thought process is exactly the same. That thought process, by the way, is exactly the same for every single function possible. But it is particularly useful here for us looking at this circle, these x and y values, when we talk about trigonometric functions. Obviously, this class is trigonometry, so that's what we're doing. Really quickly, what is cotangent? Cotangent is the reciprocal of tangent. Okay, it is a cofunction of tangent. We will we'll talk more about some of these things, but essentially, it's one like if tangent is sine over cosine, cotangent is cosine divided by sine, and tangent is if cotangent is 1 over the tangent of theta. So what does that look like visually? Well, if you saw the tangent video, the slope of this green line is essentially the value of tangent. The slope of this green line is like if you drew an angle from the center of the circle out to some point xy on the circle. And so in quadrants, when this line is in any of these positions, the slope is positive, tangent's positive. So tangent is always positive in quadrants 1 and 3. Tangent is always negative in quadrants 3 and 4. And because cotangent is the reciprocal, well, a reciprocal of a positive number is still a positive number. So the slope is still positive in quadrants 1. So, I mean, cotangent, is still positive in quadrants 1 and 3, and it's still negative in quadrants 2 and 4. But what does it mean? Like, we know if we're talking about slopes and we talk about perpendicular slopes, we hear the word reciprocal, but also included with that is opposite. Cotangent is not the opposite reciprocal of tangent. It is just the reciprocal. If I turn on the graph of cotangent, like cotangent is that slope. So a line with that slope would look like this. So this is what this looks like. Now think about what this means. Okay, if I, for example, if I ever had, if we go to like right here, right? This is, well, I don't know. Let's see, maybe, let's say for example, that the slope of this green line is 1/2, right? Well, that means that the slope of this red line, cotangent, would be 2. Okay, and so they're reciprocals of each other. It's pretty straightforward. Look, you can even see it here. Here's the graph. There's nothing labeled here, but here's the graph of tangent. It's in red, and the graph of cotangent. It's in blue. Anytime, look, this is when anytime tangent. So at 1/2, right? At this line of 1/2, tangent is 1/2 at whatever x value this is, right? It's this x value. If you go straight up, you have a value of 2 on the cotangent and vice versa, right? Anytime cotangent is 2, so 1/2, like in this scenario, tangent would be 2. You just flip what the value is, right? Now, that presents some interesting things though, because anytime tangent is 0, cotangent is undefined. Anytime a tangent is undefined, we got that from a 1 divided by 0 situation. Well, if you flip the 1 divided by 0 situation, you get a 0 divided by 1, which is just 0. So similarly, same reasoning, anytime tangent is undefined, cotangent is going to be 0. And so that's really all there is to this. I know this looks super confusing. Just quickly going to the graph here of drawing cotangent, and this makes sense. Okay, remember, cotangent essentially is the x value divided by the y value, right? So for very small y values, right? That's on the y values are in the denominator, right? And the x value is like close to 1 here. It's not 1, but it's close to it. So we would have a number close to 1 divided by a small number much smaller than 1. That's going to be a big number. It's a big value here. Okay, not super big, but relatively big. Okay, and that will follow as you go. And this is what the graph of cotangent looks like. And notice how frequently, like over what interval, do the values of cotangent start to repeat? Well, let's just say, for the sake of this right now, because you can't see really where it starts. It starts at 0, and then it starts again. The same thing here. So pi is the distance. But even looking at these points, pi over 2, how far until this would start drawing itself back over again? Well, it's right there, right? So from 3 pi over 2 to pi over 2, it's just pi. That's the fundamental period of cotangent. So all the trig functions now, they all, with the except, so sine, cosine, secant, cosecant, they all have fundamental periods of 2 pi. They all start to repeat themselves after 2 pi. But tangent and cotangent, on the other hand, they would repeat themselves twice over the 2 pi interval. So what we say is the fundamental period, meaning literally how long it takes for them to start repeating themselves in their basic form, is just pi. So the domain of, just like how the domain of secant is the same as the domain of tangent, because its cosine is in the denominator of both of those functions, the domain of cotangent is the exact same as the domain of cosecant, because we have sine in the denominator of both of those functions, right? Cotangent being cosine of theta divided by sine of theta, and cosecant being 1 divided by sine of theta. So anytime sine of theta is 0, there's issues with cotangent and with cosecant. Okay, that's it. In sum total, all these videos combined, you should have a pretty good working knowledge of all 6 trig functions and kind of how they work. I can't overemphasize how important like a deep understanding of like why does the graph do this thing it does? Not simply like this is what the graph does, right? Why does it do this thing it does? Does it make sense to you? Can you make sense of why there are asymptotes in certain equations? Why is it 0 here, right? Why is it big here and small here? How come it goes up and down? Okay, this is so much more important. A good comprehensive understanding is much better than just a superficial one in order to get a good grade. Okay, so it will help you. It will pay many dividends over the course of this class and on into your future math journey.